today's lesson is about formulating absolute value word problems. So let's look at some background information before we actually start formulating them. In an absolute value word problem, there are two parts, well actually three parts. There's the variable, and then there's the central value. This could be called the middle, central, or average value, and it's placed inside the absolute value symbols. On the other side of the absolute value equation, we have the tolerance or the range, and it's placed on the other side of the equal sign. So those are the three parts: the variable, the central value, and the range. Now, because these are word problems, when we're reading these word problems, we need to look for keywords that let us know what is the central value and what is the tolerance or the range. So for the central value, it's a little bit harder to determine what that is. You have to really read the context clues. It might tell you it is a value of or has a value of. It's much more clear if it actually tells you an average of or a mean of, or it could say to have a value of, or it might not even say any of these words. You might have to really read the context clues to determine what is that central value. However, with the tolerance or the range, it is much easier to determine what that is based on keywords. With the tolerance or range, you'll see words like plus or minus, varies or vary, the words within, more or less, an error of. So if there's anything that tells you it's within a certain range of values, any of those key words that are similar to that, that'll let you know that is the tolerance or that is the range. Okay, so let's say we have a word problem and we read it and we set it up as the absolute value of x minus the central value equals the range. Well, once you have that, you need to set up two equations after you do that. And the two equations are going to be x minus c equals positive r. Notice there is no more absolute value. It's just the inside, x minus c equals r. Or the other equation you're going to write is x minus c. Also notice no absolute value. It's just the inside, x minus c. And it's going to equal negative r. Okay, and the reason we do that is because the inside, whatever's inside the absolute value, in order for it to equal r, the inside has to also be positive r, or it could be negative r. So the inside is either equal to r or it's equal to negative r. Okay, so we're going to take a look at the first word problem. The first word problem says the mean distance of the Earth from the Sun is 93 million miles. The distance varies by 1.6 million miles. What are the maximum and minimum distances of the Earth from the Sun? Okay, so we need to find our central value and our range. If we read carefully, it says that the mean distance of the Earth from the Sun is 93 million miles. So since this is in million of miles, I'm just going to say that the mean distance is 93. Okay, and this is in millions of miles. So my central value is 93 because it says the mean. If it's the mean, it's the average. If it's the average, it's the central value. And then if we keep reading, it says the distance varies by 1.6 million miles. So since this is in millions of miles and it varies by 1.6, the range is going to be 1.6. Okay, so now the way we set this up is we say the absolute value of our variable x minus the central value equals the range. So all we have to do is plug this in. So we're going to plug in the absolute value of x minus 93 equals 1.6. And now that we have this set up, what we want to do is we want to write two equations. One where 1.6 is positive and one where 1.6 is negative. So we're going to say x minus 93 equals 1.6, or x minus 93 equals negative 1.6. Let's start with the first equation. We want to undo our operations. We're subtracting 93, so we're going to undo that by adding 93 to both sides. That's going to eliminate, and we get x equals 94.6, and this is million miles. Okay, this is in millions of miles. All right, so now let's look at the second equation. And in the second equation, same thing, we're going to add 93 to both sides. That's going to eliminate. And we get x equals negative 1.6 plus 93 is going to be 91.4. And this is in million of miles. Okay, and then the question says, what are the maximum and minimum distances of the Earth from the sun? So the larger value must be the maximum. So this must be our max, and this must be our min. And we are done solving for how many miles is the average distance that the Earth is from the sun for the maximum and minimum values. Okay, so let's read the second word problem here. The second word problem says Amtrak's annual passenger revenue for the years 1980 to 2000 is modeled approximately by the formula R equals negative 40 times the absolute value of x minus 11 plus 990, where R is the annual revenue in millions of dollars and X is the number of years since January 1st, 1980. In what years was the passenger revenue 790 million? Okay, so this gives us a formula. So let's write down that formula. We have R equals negative 40 times the absolute value of X minus 11 plus 990. Now, if we read carefully, it says R is the revenue in millions of dollars, and X is the number of years since January 1st, 1990. So R is revenue, and X is in years. Okay? Now, it tells us, it asks us, in what years was the passenger revenue 790 million? So when did R, let me not put it there, R equals 790 million. Now we know R is in millions of dollars, so we only need the 790. So we can substitute 790 in for R. So if we plug that in, 790 equals negative 40 times the absolute value of X minus 11 plus 990. So now we have an equation, and we can do reverse order of operations in order to solve. Reverse order of operations says to undo addition and subtraction first. I have addition over here, so we're going to subtract 990 on both sides. Oops, 990. Let me rewrite that. There we go. This is going to eliminate, and this is going to give me negative 200 equals negative 40 times the absolute value of X minus 11. And then reverse order of operations says to undo multiplication and division next. I've got multiplication here, so we're going to divide by negative 40 on both sides. This is going to reduce. Negative 200 divided by negative 40 is 5. So we get 5 equals the absolute value of X minus 11. Let me rearrange this. Let me use the commutative property. And using the commutative property, we're going to flip this around, and we're going to say the absolute value of X minus 11 equals 5. And now it looks like our X minus C equals R. So we can set up two equations. X minus 11 equals 5, or x minus 11 equals negative 5. Remember, one positive, one negative. And now we solve. So we're going to add 11 to both sides. That's going to eliminate. And x is going to equal to 16. And remember, x is years. So this is 16 years. If we add 11 on both sides here, we get x equals 6 years. Now let's read our word problem again, because there was a lot of information there. And it says that R is the annual revenue in millions of dollars and X is the number of years since January 1st, 1980. So this is the years since 1980. So to answer the question, in what years was the passenger revenue 790, we need to start with the year 1980 and add both of these. So we're going to start with 1980 and we're going to add both of these years. In the first one, 1980 plus 16 years is going to be the year 1996. And over here, 1980 plus 6 years is going to be 1986. So, in 1986 and 1996, the revenue was 790 million. Sorry, my marker's running out. Hopefully you can see that. So in 1986 and in 1996, the revenue was 790 million. And that is, since this is a word problem, that is our solution right here. Okay. Well, I hope you enjoyed today's lesson on formulating absolute value word problems. If you were lost at any point and you have any questions, please send me a message on Schoology or you can send me a text. Have a great weekend, everybody.